Hello Legacy Sabers, Marsh here. So today we're going to start Unit 9, Rational Functions. Today is going to be just some notes, pen or pencil, not even really a calculator, just simple multiplication today, but factoring is definitely going to be needed today. So, rational expressions, basically what are they? What are we going to be looking at this time? So a rational expression is basically a fraction with polynomials in them. So normally you're going to contain some numbers, some variables, terms, polynomials. Ultimately, what are we going to do today? You need to be able to simplify them. To be able to simplify them, and you don't know how to simplify fractions, which you've done before, how to correctly cancel, and how to factor. Now, you are not going to cancel terms, you can only cancel factors. And you're probably wondering, what does that mean? What does it mean to cancel terms and not factors? Well, how do you simplify? So if I have 10 over 12, I can make that 7 plus 3 and 9 plus 3, right? Because 7 plus 3 is 10, 9 plus 3 is 12. Well, I can't cancel those 2 plus 3's because that would be 7 over 9. That's not 10 over 12, right? Normally what you would say is, well, they both can be divided by 2. Well, ultimately in your head, what are you doing? You're going 5 times 2 makes 10, and 6 times 2 makes 10, or 12. And then you say, well, the 2's can cancel because I can divide by that, so my simplification would be 5 over 6. Same thing today. We need to be able to figure out factors, aka what multiplies to give you what, to be able to do it, not add. So, every time that you cancel out an x squared over an x squared when they're being added, a kitten dies. I know, it's quite sad, but let's try to keep the kitten population healthy and let's not lose too many kittens in this class tonight, this unit. So every time you are simplifying a rational expression, you need to factor. Do not try to cancel right away. Always remember you have to have factors. So let's actually try this simplification. What I was talking about, you can't just all of a sudden go, oh, 40x over 10x, that's just 4. That would be killing a kitten, and you do not want to do so. So let's factor the numerator, factor the denominator, and then we will see, is there anything that we can do? Numerator, it looks like I have a 20 in common, so I'm going to factor out a 20. So then it looks like I will have 2x plus 1 left up on the top. The bottom, it looks like a 10 can factor out, so I'll have x plus 3. Now, here's where I can use my simplification. I can actually cancel out 20 over 10 because I am multiplied now. So 20 over 10, that simplifies down to 2 over 1, and then the 2x plus 1 and the x plus 3 are just going to hang out because they do not simplify at all. Let's try the next one. So what can I factor out of the numerator? Can I factor the numerator? It looks like I can factor a 2 out. They both share an x, so it would be 2x. I would have x plus 4, it looks like. Denominator is just 12x. Well, since I now am multiplying, I can simplify 2x over 12x. So it looks like our x's are going to cancel off. And then we get 2 over 12, which would be 1 over 6. Like that. Next one. So I can't cancel out the x squared over x squared, guys. That would be bad. Don't do that. Let's factor again numerator and factor denominator. This is why factoring becomes so important. So it looks like 2x needs to be factored out of the top, which would be left me with an x plus 5. Looks like the denominator needs some AC method. So 3 times 5, that's 15. Two numbers that multiply to give me 15, but add together to give me 16. I think that would be 15 and 1. So I'm going to rewrite that. Do some grouping. So I got 3x right there. That would be x plus 5. Just a 1 there. X plus 5. So I will have 3x plus 1, x plus 5 in the denominator. That's what's going to multiply to give me that. Notice, guys, x plus 5s are now on the top and the bottom, which allows me to cancel off because those are factors of the polynomials. So I have on the numerator still left behind 2x. Denominator, I just have a 3x plus 1. That is done. I cannot cancel off x's because this has still that plus 1. That would be not a factor. That would be a term. And the last one for the night, x squared minus 49. I need to be able to break that one down. So remember, guys, those both are perfect squares, and I do have subtraction. So it would be x plus 7, x minus 7 in the numerator, excuse me. Denominator, I have a 2 common between all of them, so that would be x squared minus 2x minus 35, it looks like. Negative 35, add together to give me negative 2. I think that would be like negative 7 and 5. Yeah. So I'll have x plus 7, x minus 7, and then a 2, and x minus 7, x plus 5, like that. X minus 7's top and bottom. Cancel them out because I'm now in factors form. So I got x plus 7 on the top, 2, x plus 5 on the bottom, it looks like. Nothing else to simplify, so that has got to be my final answer. And that's the end of this video. See you later, Sabers.